now we're going to do the next question, which is question number 6. So now we're going to use functions and we're going to create multiple files. So we're going to let's look at the question. Decide to create a file containing a number of functions that are all used to do various manipulations of complex numbers. First, design a suitable structure to represent a complex number. See lecture notes on arrays and structures. Then code up the structure and write down suitable functions that perform the following operations on complex numbers. For this exercise, if you have difficulty on complex numbers, I suggest you go and revise. Basically, this is mathematics. You need to go and learn up how complex numbers work. Alright. You need to generate a header file and function declarations. Header file for function declaration and a declaration of the complex data type. Generate a separate C file for the function descriptions. Basically, previously when we do programming, everything is in a single C file, correct? The function declaration is inside the C file. The main is in a C file, and we always do programming in a single file. Alright, now we're going to do a concept called multiple files, where the main function is inside main complex.c. All the functions should go in functions complex.c, and the header file should be in functions complex.h. End of the day, it should have how many C file? 2 C file and 1 H file. And what should be in the header file? In the header file should have all the function declarations. So the header file, in this case, header file should have the function declaration and the declarations of the complex data type. Alright. So now let's look at you can actually find it in Startup Weekend, but it's not a complete program. We need to convert it into multiple files. Alright, the first step is we need to your dev C++ probably is open, right? So you need to close your dev C++. Close it. Right? Save whatever you need to save and just close it. Now reopen your dev C++. Okay? Once you reopen your dev C++, normally you will click on new source, right? Now I want you to click on new project. How to get here? File, new project. So next, don't click, choose a project first. So and choose console application, C project, right? And you can name the project. So in this case, we are doing complex number, right? So you can call it complex project. Okay, so I'm going to click OK. Then it will ask you a place to save. So what do you do in this? I'm going to use my documents. Create a folder. Okay, what should we call it? Maybe we call this complex number. Make sure your C file and .h file are all in the same folder. It cannot be in a different location. Huh? So the name of my folder is called complex number. The project file, this is a project file, we save into that folder. Alright, the first thing it will do is it will show you a skeleton main.c. Next thing you need to do is go to project view, click on the actually the class browser is there. Class browser is there. Okay, this is called a class browser. If your class browser is missing, okay, open it. Sometimes what happened was like mine, it was hiding in the corner. Okay, you need to unhide it. Okay, so alright, you have this. So you know how I got there. Go to view, class browser. Okay, so it's already created a main. So you see this thing, this skeleton here, I want you to delete it. Okay, and then I want you to click save. When you click save, where should you save it? You should save it in the same folder which you create. It's not complex number. So we call it main.c. Okay, now right click on your project add new file. And is it untitled 2, right? Right click, rename. Right click this thing, rename. Let's call this functions.c. Okay, right click on this, add new file, untitled 3, right? Let's rename it header.h. At this moment, you guys might be confused. Say, sir, how come over here we are using main complex.c, functions complex.c, and here is functions complex.h. Meanwhile, you are using main.c, header.h, function.c. The reason is actually it doesn't matter what the file name is, except that your project must have 2 C file and 1 H file. So what should be in the main.c? All the main function should be there. Main function should be there. All the function declaration, function definition, the one below the main should be in the function.c, and the header.h should have all the declarations. So function declaration and the complex data type declaration. Okay. So alright. So we have done this thing. So this is when you want to use multiple projects, you have to do this. So you click save, then ask you where to save it. Save it to the same folder, and this is complex number. So all the header.h also goes to the same folder. So make sure they are all in the same folder, and the project file also is in the same folder. Okay. Alright, so this is how you have multiple projects. So now let's solve this problem. Actually already solved it. It's in your startup codes. So how to find these startup codes? So you can actually go to practical. You go to Moodle topic 08. So you click on lab 8-9 exercises. Open that, you'll find this. So you go to startup codes. Okay, you can just, it's already open for you. So if you scroll down, okay, it's not week 8, it should be week 9, I guess. Don't say week 9. Week 9. Okay, yes. The first part is the function declarations. Okay, so now where do we actually find? So this is you look for the main function. So this is the main function, right? So we steal the main function. So in this main function, okay, how do you know it's the beginning of the main function? It's the end of the main function. Okay, this is the main. Where should the main function go? It should go into the main.c. Okay, and why is there a getch here? Getch here is you are using an older version of Dev C++, then you can have a getch. You can remove it. So there are a lot of inside a main must have all the function call. So let's identify what are the function calls. There's a print function. There's a magnitude function. There is a calculating the complex angle function. Then there is a add complex number function. Then there's a subtract. There's a multiply. There's a divide. Right? All these are all the function call. It's not complete, right? Must have function have how many parts? Function call, function declaration, and function definition. The function declaration. We're in the wrong place lah. X. It should be in the main. Don't make that mistake. Don't make the rookie error. Put it in the main.c. And the header.h should have all the function declaration and the structure declaration. So this is the structure declaration, and this is the function declaration. Copy. This one should have. So header.h has structure declaration. Okay, remember, you know a little bit about structures, right? So when you put a type def here, what happens is this word complex has the same power as int and float. See how? Just to give you an example, right? So when you declare int x, what happens? int has a power, right? So it gives meaning to x, right? So when you use the word, when you put type def followed by structure, so the word complex has some power. Okay, what is that power? It has a power to become like a data type. So there is a new data type called complex. So let's see, look at the function declaration. So result, what is it? It's a type of complex. First thing you know, ask a question. So what is actually complex? Complex is actually a structure. So inside the structure has how many variables? 2 variables, real and imaginary. So you see this word result here? It looks like a single variable, right? But I see there's 2 variables inside it. Result.real and result.imaginary. Same over here. Num is a type of complex. Complex is what? It's actually a structure. And inside the structure there is 2 variables. So inside num looks like a normal variable, but in num there's 2 variables hidden inside it. Num.real, num.imaginary. Same over here. Num. Now look at this structure here. Add, right? So we add complex number 1 to complex number 2, and then we have a result. We have a result. When you add 2 numbers, you get a result, right? And why this thing has an asterisk? Normally when you have an asterisk, this is a reference. So you pass the reference. So we send num1, num2, and we don't need to do a return. We get it pass. We get the result as a pass by reference, and therefore this function has no return, and therefore it is a void. Same. This one has also a void. This one void because it's just a printing function. Printing function doesn't need to have a return. So this subtract num1 minus num2, they get result. Num1, num2 multiply, then you have also divide. Okay, so what are these? These are function declaration. So function declaration and structure declaration, they go into header.h. So make sure you save it. Alright, so this is how you do it. So now let's go back. So what's missing now? Main is done. Okay, we need to go to the main, header done. Functions.c. So what is inside functions.c? What is inside function is actually the function definition. Where do you normally find the function definition? Is below the main. Okay, let's scroll down. Below the main. Alright, it should be below the main. Alright, it should be below the main. So go to below the main and we scroll and we can find all the functions below the main. Okay, these are all the function definition. Okay, don't go here. So okay, all the way here, function definition. Copy and we paste into the function. So now we need to, you have 3 files, right? We need to link it together, right? So you look at the main. So the first thing we need to do is we need to link this to our own. You see, we are using printf, right? Printf, did you invent printf? No, right? Somebody created it, right? When somebody created the function, they put the specification for the function inside the include stdio. If you want to refer to a header file which you created, what's the name of the file, header file? Header.h, right? Include header.h, but we don't use the angular bracket because this is a user defined header file which you created. Okay, so and the tricky part is you cannot compile each file individually. You have to compile it as a group. So if there's a mistake in any of the files, then you have a lot of errors. Okay, now let's look at this. Let's finish this up. So declaration. Now there's something interesting. So this is the functions file, right? Does it have a printf? So if there's a printf, what do you need? You need to include stdio.h. Now if you compile, I think there will be still some errors. Okay, you see unknown data type name complex. So where is it declared? It's declared in the header.h, right? So include header.h. Moment you do that, if you compile rebuild, compile, and run, it should work. Is there any errors? SQRT. Do you know why there's a SQRT error? Because SQRT comes from what function? What header file? It comes from math.h. Math.h is a built-in, so we use angular bracket. So compile, run. No more warnings. Okay, so this is the output. So the two complex numbers is 4 and 2 and 3 and -1. So magnitude for each complex number 1. So this is the magnitude. This is the angle in radians. Alright, this is the, when you add the two complex numbers, this is the value. Subtract. Remember, when you add two complex numbers, you get a third complex number. You subtract two complex numbers, you get another complex number. So that's the whole purpose of this project. So what are the things you need to do to make it work? Before I explain the code meaning, you need to create a project, new project, a C project. You create 3 files. You can name them anything.c, anything.c, and header. So in the functions.c, you have all the function definition. Normally function definition is below the main, right? Now you put them into a separate file. And main.c, you put the main function inside the main.c. Alright? And you put all the function declaration and also the structure declaration inside the header.h. And from the main, you have to refer to the header that you built, include header.h. And from the function, if you want to use the data type that is declared there, you have to use header.h. If you want to use square root, you have to use math.h. And over here, you're using printf, right? So you have to include stdio.h. So this is the function definition. So at the end of the day, previously, now the question been asked, why do you have to have multiple files? So when you have a big project like Microsoft, let's say you are the developer for Microsoft Office. And Microsoft Office has like 3,000 functions. Imagine you have a single .c file for all 3,000 functions. That's a long file, right? And remember, normally you have like 500 people working. You're not going to work on 500 people don't share one file, right? So the idea is actually, if in a company, they'll divide it by one function, one file. In this case, all the functions, we put this into one file. So now let's look at the next stage of this part, this thing. All right, we want to look at how this thing actually works. Right, how does it really work? So let's look at this. So first thing, let's look at the main. So first thing is complex acts like a data type. Why does it act like a data type? Because you have declared it with typedef. Typedef struct, and this variable represents this structure. So when you declare num1 is actually a type of complex. Complex is actually a structure. Inside the structure got 2 variables. Remember, what is a structure? Structure is a container that contains other variables. What is an array? Array is a variable that contains multiple data. Okay, so now num1 has how many variables inside it? So remember, what is a structure? Structure is a container that contains other variables. So num1 has 2 components, num1.real and num1.imaginary. And because they are just a normal variable, you can assign values to it. See, 4.0, 2.0. And over here, you can, like num2. So you declare num2. You can also assign num2.real, 3.0, num2.imaginary, -1.0. So the idea is you can declare as many variables as you want. It's just like float, magnitude 1, magnitude 2, you can declare. But the thing is that when you declare mag1, mag1 is a type of float. You can only store floating data, one data. But num1 is a type of complex, and complex is a type of structure. Inside the structure, there's 2 variables. So num1 has two variables inside it, num1.real, num1.imaginary. Num2 has two variables inside it. The whole idea is, what is a structure? It's a container that contains other variables. Alright, let's look at this. So you have this magnitude. So you call the function mag, you call num1, and let's look at a function declaration for magnitude. So over here it receives the complex num. Alright, and this is the function square root. So this is the function to find the magnitude for complex number. So this formula you have to know is for mathematics, and then you can just return one value. So because this has a return, the data type is a float, and when you have a return, you must have somebody receive. Somebody return something, you must have something to receive. Alright, let's look at another one. Let's look at addition. If you look at addition, now you see, when you look at this is a function call, correct? This is a function call. Now this function call is very interesting. This is num1, normal variable. This is num2, normal variable. However, this one is a what? Pass by reference. Do we need to have a return? No need, right? The idea is, if you use pass by reference, you can actually, you don't have to return it. You don't have to have a return statement. The moment you store it in result, it's already passed. So it's passed by reference. So now this is a function call. Now let's look at the function definition for addition. Alright, so complex num1, complex num2, and result. Now over here, okay, there's actually two ways to do this. Basically, this is basically the same as this. Okay, it's the same thing. Basically, this is because this result, is it a normal complex number? It is this is a reference, right? You see an ampersand. So instead of using the reference symbol, there's a shortcut for using the reference symbol. They use the arrow symbol. So instead of doing that, we do this instead. Alright? So this is just basically, this is how, when you want to use references together with structure, you have to use this arrow symbol. So if you see num1, is num1 a reference? No, right? So you just use the normal dot notation. Is num2, do you see, is there num2 have this symbol? No, right? So you use num2, num1, you just use the dot symbol. But if you're using this is instead of sending the see, when you send a pass by value, you're sending the value, right? Basically, when you call this result with the ampersand result, when you call the function, how do you call the function? You call the function with the result with the ampersand, right? You're sending the address to the variable, or what? Address to the structure. This one, you're sending a copy of the structure. When you call this function and send num2, how many variables are you sending? You're sending the value for num1.real, num1.imaginary. Remember, num2 is a structure variable. A structure is basically a container that contains variables. This is not sending the whole container. You're sending an address to the container. When somebody sends you address, you need to activate the address, right? How do you activate? You use the asterisk. Okay? And when you want to use you want to access, this is a container, right? This is an address to the structure. So you want to access it, you have to use the arrow notation. But if it's just a normal variable with normal structure without this asterisk, that means not a reference, you use dot notation. So that's the only difference. So now we do the first calculation. You add up to number. How do you do addition? This is mathematics. num1.real plus num2.real. Then you get result.real. num1.imaginary plus num2.imaginary. Then you get result.imaginary. So do we need to do a return? Why? The moment when you do this operation, is automatically already linked, because there is a link. When you use this pass by reference, this is a link, remember? So do you need to return? No need. So therefore this function is a void. For the rest, they're also the same. Subtract, divide, multiply. This how they actually work. is actually related to mathematics. When you want to do division, you have to first create the denominator, then you insert this formula and divide by the denominator to find the result.real and result.imaginary. So remember, this one is for normal variable. When you send the pass by value, if you're going to pass a reference, you have to use to access the variable inside the reference, you have to use the arrow operator. Alright, everything else is the same. You can see it's just repeating itself. Over here, why is there a float? Because you're returning you're returning a formula. This formula is tangent, and you will have one variable, one value. So you return one value, the value is a float. That's why you have a return here. Okay, over here there's no return. So why? Just print it out. There's no return. So we decide not to have a return. Okay? So remember, when you declare, so the basic concept is when you declare a complex number, num1 is a type of complex. Why complex has this power as float? Because you use type def. So remember, when you declare complex num1 is a structure. The structure has how many variables? 2 variables. So basically, this is how the basic concept of multiple files and structures and passing structures to functions. Alright, previously we passed a 2-dimensional array. Now we are actually sending the structure to where? To the function. So why are we learning this? Let's look at it. So you see, when you do addition, right? You're sending num1, num2, num3. How many variables you're sending? Actually sending 6 variables. But the beauty is, when you use a structure, you only send num1, but inside num1 has num1.real and num1.imaginary. So you actually it's basically a container that contains other variables. That's what structures is all about. So you need to make sure they are in three files. This is multiple files. The reason for multiple is to make group programming easier. In the workplace, every function will have its own file. Okay, but in this case, we only have 3 files, 2 C files and 1 H file. And when you compile, it should show you that. Okay, thank you.